The next speech, you're both here, I'm very glad. So we have two Julien, Julien Bois and Julien SPANNEUT. Huh? So grab one mic,
So, hello everyone, I'm Julien SPANNEUT from SNCF Voyageurs, and I will present you today with Julien Bois from SBB the evolution management process of software on a safety-related system, which is the Okora ETCS system.
So Julien Bois, I worked 9 years for Alstom as safety manager on most of the safety product, SEAL 4 product and SEAL 2 product. And now since 2019, I'm working for SBB, and for ICOS in a mission for SBB in innovation project. So as safety manager like Smart Rail Firnul, Okora, and now Europe's Rail.
So on my side, I'm head of rolling stock software for SNCF Voyageurs in the rolling stock engineering division, working there for 15 years. I've been TCMS engineer, door system engineer, software engineer, and I'm also expert in software, safety and maintenance, working in Europe's Rail, Shift to Rail, Okora, Eurospec, etc.
So Okora means Open Control Command System Onboard Reference Architecture, so it's a terrible naming, but easy to understand with Okora. So the goal is to define future requirements, functional and non-functional one, for to have an harmonized set of requests for future call for tenders for the suppliers. And because today the CCS onboard systems are made according to TSI CCS and its related subset, which means this is a monolithic architecture. And the problem is that every time you are making a modification, it impacts the complete certification process. So to prevent this, Okora splits this monolithic architecture into a modular one made of interoperable and partition building blocks. Interoperable in the meaning of Okora means fit farm functions equipment, interchangeable between different suppliers, and partitions mean that they will be free for interferences between safe, non-safe, and secured partitions. And these building blocks will be smaller and easier to update during their lifetime, but they will require a stronger effort during the integration phase, which is a major task for Okora.
So, over the 30 years, sometimes 40, sometimes 50 years of lifetime of a CCS system, we have to update the software. For several reasons. It can be to update the safety, the maintenance, the cyber security, the reliability. So we needed to define a process, a common process for all the Okora suppliers which will provide a system. So for example, we need to patch the system for cyber security reasons. We need to add some functionalities like ATO. We need to adapt to new technologies like FRMCS. Also, as a train operator, we need to have updates for the maintenance part, like for condition-based maintenance, for predictive maintenance. So we need to have fast and frequent updates. So the CCS onboard systems, they have to be compliant with the European standards and regulations, which are quite strict, because we have to ensure that the safety is guaranteed for the passengers. So we have, for example, the CSM risk assessments, we have the TSI CCS, we have the EN software and the safety standard, which are 50126, 50128. Next, we will have the 50716, which will replace the 50128. So we need to be able to develop fast and deploy fast our softwares on the CCS system. It's something that we cannot do at the moment because the CCS suppliers, they have to deliver, let's say, big versions to amortize the fixed cost of a version. So usually it takes really years to have a version on a CCS, and it cannot allow the train operator to have a specific item for his CCS system. So we wanted to have an efficient change evolution system, and we also wanted to have a fast assessment of the evolution to allow to be able to easily update the software remotely.
So now I'm just going to present you the evolution lifecycle, evolution management lifecycle. So first, you have an evolution which is required by railway undertakings. Basically, it could be, please provide me an update for this bug fixing. Please provide me this new functionality. Then this request is sent to the suppliers, which perform their internal an impact analysis based on their internal process, showing, okay, what would be the impact on my deployed system? And then it will deploy this evolution management process, which in fact gives you a common frame for development and test activities with this modular architecture, which we'll detail in the next slides. And then he applies the modular testing strategy, which is also under development by Okura and ERGU, which provides a standardized list of regression and non-regression tests at building blocks level, then at CCS level, at vehicle, and then at full system level to avoid rethinking the complete scope of tests at each update. And then, based on the result of this evolution and testing strategy, the supplier has an adapted process of development and test activities to make the update, which will be shorter than the usual way to do, and then an optimized level of assessment focusing on depending on the criticality of the modification.
So the evolution management process that we have been defining with our Okura partners, it is based on existing standards and regulations. The CSM ERA, the Swiss RTE 49100, the EN 17023, and also some internal processes that we had. It is applicable to any type of modifications, hardware, software, electrical, anything. It is using 7 criteria to analyze the modification. There are the CSM criteria like failure consequence, innovation, complexity, monitoring, reversibility, additionability, and we added also cybersecurity. It is defining the development process that will have to be applied, for example, for software, how to make a fast evolution. Do we have to apply a complete software? And it's also defining several levels of assessments.
And now let's say, how do we evaluate each of these criteria, which is not defined by any standard? So basically, each criterion is evaluated by answering a list of standardized questions or by using a specific KPI that we have defined. So here we just take the example of the innovation criteria, which is also called novelty in the CSM. So novelty means it's something either new for the railway sector or from the company using the CSM. So the example we would like to take is just that we have a box that would be called localization on board, which is the functionality of taking the information from the balises and from the satellites and to provide to the track side the position of the train. And on this box, which is, let's say, imagine it's already deployed and fully working, you have an update required to provide diagnostic data to perform online monitoring activities. So then, okay, you will come to this point and say, okay, first question, can a technical code of practice be used to realize the evolution? Now it's yes, because it will be the new subset 149 for online monitoring that will be available in the coming months. Then has the evolution already been successfully deployed by the company? No, because it's something new, so the company has never deployed this before. Then does the evolution remain in the actual state of technique? Yes, because it's not a new programming language, it's not a new technology, it's just additional maintenance data to be provided from onboard to trackside. And the last one, does the evolution correspond to the reference system defined by TSI CCS? Yes, because subset 149 will be delivered with the TSI 2023 by the end of the year. So that's the way we are managing these elements. And this will be used to define the correct level of software development for the future. Sorry. So, then when you have these answers, you say, okay, how many yes do I have? If you have 4 yes, then it's minimal impact. 3, it's low. 2, medium. 1 or 0, 1 is high. So in our case, we said, okay, it's low. So, okay, my bad. Not the last presentation. So it's low. I'll change the example to make it simpler, but it's low in our example. So my apologies. So this will be used to have to define the level of all these criteria made like this will be used to make the software development process.
So we are combining the results of the analysis of 5 criteria: innovation, complexity, monitoring, reversibility, and cybersecurity. We combine them together and we define what we call a safety score. The safety score, in this example, we are combining all the data, all the green cases, and the safety score is an input for the software development process and the assessment process. The 2 other criteria that I mentioned before, the failure consequence and the additionability, they will be used later in the process also.
So here we see that based on the different criteria we defined, we define 3 levels of significance: minimum, medium, high, which are then combined also with the failure consequence criteria. So on this table, we see that we have what we call the minimum impact will be only used for basic integrity level partitions. Then for SIL1 and SIL2 partition, it will be a balanced level between medium and high. And for SIL3, SIL4 partitions, most of the time we will only consider high impact because of the criticality of the systems. We have less margin, let's say, to consider something which is medium. And then, based on this, the additionality criteria is used used in addition to this to define the final level of assessment.
So for the software development process, we have to use an EN standard, which is EN 50128. It's describing how to make an evolution of a safety-related software for the CCS. There are 2 types of evolutions which are defined in the software standard. There is a major evolution. In this case, you have to apply the standard completely. So it's a long and complex process. It's costing money. And you also have the possibility to develop a minor software evolution. Then you have to apply only a part of the standard, which is defined in the software maintenance part of the standard. It's allowing to have a faster and lighter process of development. The only problem is nothing is defined in the standard to define what is major, what is minor. It's up to the supplier to have the criteria. As in Okora, we will have several suppliers for the different building blocks of the Okora system. We needed to have an harmonized way of defining the types of evolution. So minor evolutions, they will be deployed much faster. So it's a key element for the development of and the delivery of patches and things like that. So complicated too. So we are using the data from the previous table that we saw that with a minimum, medium, and high impact. If it's a minimum or medium impact, we are allowing to use the minor evolution of the EN standard. So basically, in case of minimum and medium impact, we will use the lighter process defined in the 50128. If it's a high impact, we will apply the full process.
And then once you have defined the development process, you have to ask yourself, how will I make my assessment? So why do we have these 3 shades? It's because this evolution management provides 3 shades of assessment. So in case of minimum impact, we have what we call a yearly letter of support, which means that the evolution is managed internally by the supplier through its internal quality management system. And the latter is provided once a year to the HISA for evaluation, and then it will amend the last valid certificate with all the minor versions provided. In case of minimum impact, we have a letter of support, which is in fact a dedicated V-cycle made on specific documentation for the evolution itself, which is which is not mentioned in the safety case. It's another parallel set of documentation which drive the evaluator to make an evaluation only on this reduced scope of development, and will issue an addendum to the safety case. And in case of high impact, it's a new certificate, meaning it's a usual way to perform safety modification in safety product. It's a complete reassessment. And this is where comes the additionality criterion. So basically what we want to handle with the additionality is that this criteria is based on the number of letter of support emitted since the last valid certificate. We also take into account the safety score, meaning after the last valid certificate you may have 10, 15 letters of support, but after a certain amount of this one, we said, okay, we cannot guarantee there is no side effect between the first and the 14 ones, so we can do a complete reassessment on the product, and then we can start again with small evolutions.
So what's next? The OCORA evolution management process will be transferred, extended, and we will update it in the Europe's Rail system pillar starting next year. Why? Because the scope is much wider in Europe's Rail. It's not only the CCS on board, it's also the CCS track side, the jack, etc. There are many other systems. And we will start to work on it with our railway undertaking partners, with the infrastructure managers and the suppliers also. Thank you.
Thank you.